encompassed within what we call the crust of the Earth. And the crust of the Earth, even with all those mountains and deep trenches, is only about the thickness of the skin on an apple. So the crust that we know, with all its mountain ranges, is only that thick. Underneath that, you get down into the mantle, and the mantle runs all the way down. There's the upper mantle, there's the lower mantle. You know, we can get technical, but let's not worry about it. Until you get down into the core. And the mantle is all sort of a squishy, semi-plastic material. Mantle rock is metal, it's very dense. The thing you have to remember is that the surface of our Earth, the skin of the apple, it's not entire. It's actually broken up into plates. And the plates actually drift around on that semi-molten mantle. And what actually makes them move around are the convection. Yes, well, we're going to subduct some of this stuff with all the silliness. So the heads are going to be the continents. We're going to let their shoulders represent the continental shelf and the continental slope. So like the Grand Banks of Newfoundland for Canada, except this is, remember, a long time ago, so it's not exactly the Grand Banks as we know it today. Or if you're more familiar with places, well, I'm trying to think what the equivalent would be in the States. Really all of the banks, George's Bank, Brown's Bank, you know, all of that, that's all part of that continental shelf. It's part of the continent, but it's actually out under the ocean. So that's what the shoulders represent. So this is kind of marine environment, and there's all kinds of, you know, stuff washing out of the rivers that's kind of depositing. Well, it's happening over here too. But it's building up. Yeah, but it's building up those continental shells. And then I'm going to ask you to stretch your arms out. Well, actually, you only need to spread these two. So step apart. Yeah, and just rest. Just touch your fingertips so you can rest your hands.
We're bank to bank here.
Yes. Now, the oceans, though, because the ocean floor or the ocean plates are actually slightly denser material, they tend to sag. So we're going to have the ocean sag a little bit, and because it sags, it fills with water. And it's salty because of the runoff from the land carries dissolved salts from all the rocks around the land. Now this is very simplified, but sometimes a picture is better. Okay, so old North America, old Europe. What we have in the middle of these two plates is we have a zone where the plates can either move together, they can move apart, or they can move laterally. Those are the three interactions that you get at plate boundaries. If you get two continental plates meeting, they thrust up and form a mountain chain. That's what's happening where the Indian subcontinent is colliding with Asia, and we're getting Everest rising today. When two plates move apart, as is happening today in the middle of the Atlantic Ocean, you get a rift zone. You get the mid-Atlantic rift, where magma from this mantle wells up, spews out on the ocean floor, and actually forms new ocean floor. Or if two plates move laterally against one another, as is happening where the Pacific plate is moving north in relation to the North American plate, you get somewhere down in here, there is this mantle rock. This is the source rock that the lighter part fractions of will, as it's melted, the lighter fractions will rise up, and as these plates move apart, it creates like a lighter area, and that allows some of the lighter rocks to come up and spew out. That's what would be happening normally. What happens when the plates start to move together again, and you have ocean plates, one of them is going to be subducted. That's that word there. One of them is going to be driven down under the other. So what we're going to do is I'm going to get you to hold the piece of rock, and the plates are going to move together, and this is going to be subducted, and what's going to happen is this is going to be pushed down into the mantle. It's going to get really, really warm, it's going to melt, and eventually it may spew up and form more volcanoes. And actually, that spew up. Well, you know, whatever. Meanwhile, this part of the plate is, they're moving together. Actually, they're both moving, so we move very slowly. This is still kind of deeper down, like I have to have them hold it, so that's why it looks like it's higher up, but in fact it's deeper down in the ocean. As these two plates come together though, what happens, even though one is subducting, there's a lot of friction, and this plate plate is actually picking up bits of rock from the ocean floor. It's picking up some very, very deep ocean sediments, some real black muds and shales. Then as it moves along, it starts to move up onto the continental slope, onto the continental banks, and it starts to pick up the shallow water, very fossil-rich limestones. Then as it moves even further, it gets up into that sort of shallow, near-shore area where you had all the sediment washing off the land. Those beautiful sandy beaches, for example, that are represented in the quartzites on the top of slight areas of calcium. Well, actually, it should actually feel a little bit greasy, almost like soapstone. And like I said, serpentine actually is a soapstone, or soapstone is a serpentine.
Yes, that's marvelous.
That's moss campion.
Oh, that's
Yeah, it's a. Now you might have seen it at Cape St. Mary's, but it was probably so overgrown with all the grasses that it might not have stood out. It's incredibly dense. It's a plant that's really typical of a lot of Arctic-alpine plants. It's beautifully streamlined, so the wind can just kind of, flow right over it. It stays close to the ground. I mean, today it's a nice warm day, but you can still feel the wind. When you get right down close to the ground, you'll find that the rocks are warmer, and there's a still layer where there's hardly any wind at all. Moss campion also, in order to get at that water, has an incredible taproot. A plant that size could be 50 years old, and it could have a taproot that goes down maybe 4 feet.
Wow.
In order to tap into that water supply.
It looks like it's just covering the rock.
Yeah.
It's very
Yeah.
And it's had a bloom on it, or is that
Yes,
the color
yes.
of the bloom?
No,
Was
it has a beautiful pink-purple bloom in the spring. It flowers in June, and again, that's like a lot of Arctic-alpine plants. As soon as it's warm enough so that they can start flowering, they do. Because again, close to the ground, when you get the sun on you in early to mid-June, even here it starts to warm. These are stems that are dead, but I suspect they're all connected. I think they're part of the gin. This is ginberry.
And then
or juniper.
Juniper.
Now,
Yeah.
and that little
That's the moss campion, which is like the little one
Okay,
that we
over
looked
there.
at up there.
Be a good master's
Veritable
thesis.
treasure
See
trove.
how long it takes to do
Yeah.
how to make a drug basket.
We had the Minister of the Environment from Iceland here yesterday, and the head of the Park Service there, and the Minister of the Environment from Belize, or actually not Environment, but Natural Resources, and his head of Parks, and which is kind of a bizarre group to have during a field trip in a boreal national park, but they wanted to learn more about how we manage Canadian national parks. But when the Icelanders saw this, I didn't have to say anything. They just ran over and they would say, "Oh, it is so beautiful." And I said, "What do you call it?" And they said something in Icelandic, and then one of the guys translated and he said, "Wool moss." And I said, "Yes, wool moss. That's exactly what we call it, gray wool moss." But they recognized it instantly.
I am Rhode Island, to the lovely shores of Newfoundland. I traveled many a mile. The people they are land. There were Kellys, Murphys, and Malones, O'Briens and O'Lear. The finer bunch of lads and boys as ever can compare. As farmers and as fishermen, we came across the sea to the lovely isle they call Newfoundland. I sang it home to me.
That's Maryland.
To Carboneer and on to Old St. John's. You'll always find a welcome there. You'll hear some Irish songs. But it fills my heart and it fills my eyes to hear those songs again. And it makes me proud to tell you that an Irishman. The time has come and I must go to the land across the sea. The lonely isle they call Newfoundland, we're still recalling it. For their mines are hills and her mountain glens, there is no land. God bless and keep you as you are. We love this smiling land. God bless and keep you as you are. We love the Newfoundland. Okay, one more little jingle song for you.
Under the stars.
You know this? Okay.
Under the stars.
This. Oh, you want to look at the stars? We're here. Oh, the other stars.
Oh, right.
There's a lot more of them. We'll do Eyes to Buy before we get going. That song was written by John Cabot, so it's not new. Eyes to buy the building, eyes to buy the sail there, eyes to buy the picture. Come on, guys, if your partner's anywhere, if your partner's anywhere around, oh, we're gonna get home and back all around there. Well, I don't want to make any picture, I'm going there, I can buy the picture. Come on, look at the star, if your partner's anywhere around, oh, we're gonna get home and back all around there. If your partner's anywhere around,